introduce Roger and the EVgo team here to kind of talk a little bit about GraphQL and what they're doing over at EVgo. So thank you for joining us, and sorry for the technical difficulties, especially with the links, and I apologize. Getting familiar with this stuff, so I apologize for that, but hopefully the presentation's good and we'll get started. So I'm going to pass it over to Roger so he can speak and tell us a little bit about EVgo.
Yes, hello and welcome to our first Tech Talk on this lovely Friday afternoon. I know everybody's ready to get their weekend started, so I'm just going to hop right into it. My name is Roger Nikkinen. I'm the Director of Software Engineering at EVgo. And the team that is going to be speaking today, Sharif, Brandon, and Juliette, are all very talented engineers that are on our team here at EVgo. EVgo was founded in 2010 and is one of the nation's largest public fast charging networks, serving all fast charger capable EVs and more than 500,000 customer accounts. We got 850 fast charging locations located in more than 30 states and 60 plus nationwide markets nationwide, metro markets nationwide. We powered more than 280 million electric miles to date. And we are in pretty much all of the major locations. We try to serve customers where they live, work, and play. And we specialize in locating charging stations at convenient locations like grocery stores, retail locations, shopping centers, as well as parking garages, hospitality, etc. More than 140 million people live within 10 miles of one of our chargers. And one of the things we're very proud of is that we are powered by 100% renewable energy. We've been powered by 100% renewable energy since 2019. For every kilowatt hour consumed on our network, EVgo purchases a corresponding kilowatt hour renewable energy credit from an accredited REC supplier. We specialize in fast charging. We are building thousands of new sites with 100 to 350 kilowatt chargers. And more recently, Tesla drivers can now access our network with the new CSS combo adapter that's just been released. So that's kind of a little highlight about EVgo. As a software engineering team, we have been working very actively and have our mobile apps and a lot of our apps that are out there powered by GraphQL, specifically Apollo federated graph. So we really wanted to kind of bring to this conversation today kind of like things to think about if you are considering using GraphQL within your company, talking about strengths and weaknesses and things to think about, right? So without further ado, I'm going to pass it off to Brandon, who's going to talk a little bit about Apollo Federation, GraphQL. Thank you.
All right, thanks, Roger. Can you guys hear me okay? Okay. I'm Brandon Ramsey. I work for EVgo. I am from Kansas City, spending today in LA with my team, which is great to miss some of the cold weather that we're getting now. But yeah, so like Roger said, we use federation on our GraphQL graph, Apollo managed federation at that. And the big thing with federation and what it gives us and why it was the right choice for us is that it allows us to separate concerns, keep our code bases specific to individual teams that work on different parts of our data, and also allow, kind of limit the cognitive overload or overhead that it takes to that it takes to work with any of those. So it lets each team kind of focus on the stuff they know best and not have to worry about the entirety of the graph, and not have to worry too much about dependency management or other things. It also allows, running the subgraphs as services allows us to address some scaling issues where some services may have different performance needs or different compute needs. It allows us to tackle those individually. You can go ahead, next slide. All right, so for some of these examples, I'll just set up like a really simple federated graph. Or right now we won't use a federated graph. We'll just talk about a couple of databases. So one, we've got books, another we've got authors. We've got 4 books, Cat's Cradle, Slaughterhouse-Five, Breakfast of Champions, The Old Man and the Sea. And for those 4 books, we've got 2 authors. Kurt Vonnegut wrote the first 3. Ernest Hemingway wrote the 4th one. And we can assume that like each database and its corresponding API is managed by a separate team, probably a separate repository, maybe 2, depending on how we set up that graph and database. Go ahead and go to the next one. All right, so without federation, each team essentially manages its own GraphQL API and its own database. They are essentially run as completely separate entities. We end up with, without too much work, we end up with 2 separate APIs. Front end basically needs to remember 2 separate authentication processes, 2 endpoints, 2 sets of secrets, all the stuff that comes with, all the environment stuff that you have to have in order for a front end to connect, or a client of any sort to connect to a database or an API. Yep, you're good. So with federation, it allows us to fix one part of that problem, which is multiple APIs. So we end up with federation, the individual APIs get combined using it behind a single endpoint. So reducing the amount of secrets that front end needs to handle. With federation, the graphs are essentially, the 2 subgraphs are kind of combined, and I'll go a little bit more into that later on. But an alternative to that, and what was more popular before federation got some steam, was schema stitching. Schema stitching is nice, and it can even handle some more manual use cases, like non-GraphQL APIs, things like that. But it is another service that needs to be managed, and then it kind of breaks that separation of concerns, because usually it's going to be multiple teams that handle the multiple GraphQL subgraphs. They're each going to be kind of collaborating on that router or schema stitching gateway. With federation, the gateway or router is kind of responsible for putting the query plan together, looking at the graph, looking at all the resolvers, and determining how it's going to collect that data. And then it collects the data from the APIs as necessary, makes all the calls, and then returns the completed query back to the client. We use Apollo managed federation, and currently we're on Apollo Gateway. We're in the process of switching over to Apollo Router, which is Rust-based, way faster. And some of the managed tooling we get with Apollo Federation is there's a tool called Rover CLI that can do cool stuff like on merge, or to a pull request, like checking schema changes and making sure we haven't removed or deprecated a field that's in active use or has been in the last 7 days, things like that. And it can also, obviously, as a pull request check, make sure that we're not breaking any part of that federated schema. Since we're separated in our concerns, our repo doesn't necessarily know what's going on in the supergraph or in any other subgraphs. So that Rover tool helps make sure that we're not doing anything that will break something after we merge it in. Go ahead and go to the next one. So with the types, what the GraphQL types might look like in this example that we were talking about is we have a type called book with a unique ID, and maybe we just have the name. I'm sure we'd have some other stuff. A type called author with first name and a last name, also a unique ID. A book's query, a single book query, an author's query, a single author query. Pretty simple stuff. The individual types don't have any links to each other just yet. We'll talk about that a little bit in the next slide, but that's part of keeping these the separation of concerns. Like, we don't necessarily want the book group to need to worry about what the author group is doing, either with their data or with their subgraph. And conversely, we don't want the authors group to have to worry much about what the book group is doing. Jump into the next slide. All right, so in order to extend these and give each team kind of control over its domain, but also allow us to use some sharing of those pieces, this is kind of what it looks like. So you notice at the top of this books object, we've added an author that this would, in GraphQL, would allow us to take a book and its author object. The queries don't change. And then also in author, we've added a books array to the author object. So when we query an author, we can get all of the books that that author has written. But in order for this, we have to have the types to reference them. Like we can't use author or book in either of those graphs if they don't have any knowledge of it. So you'll see at the bottom of each of those blocks, kind of how that's handled. So with a federated graph, GraphQL will combine types, but if a similar field exists on two types, it won't allow it because it doesn't know which of the subgraphs should be like the source of truth for that field. So the way get around that, or the way we instrument that, is with that @key decorator, and we specify like essentially, okay, number one, this field it's really just here for tracking purposes. It's here because it's the unique identifier, and I'm not the source of truth for this. That way, when these two subgraphs get merged, the author group gets to kind of maintain control over that. And when GraphQL coalesces everything, it's not going to complain, because it's going to know that author is the ultimate source of truth, and it's not going to treat that as a conflict. So that's kind of a really brief overview of federation. There's a lot more stuff. It obviously gets a lot hairier in code and in the resolvers, and you can do things like defining entities and a lot of other stuff that you'll see if you can check out Apollo's federation documentation. It's amazing. But yeah, on top of that, we'll take a little left turn and talk about some of the caching techniques we use with DataLoader and a common problem with GraphQL queries. So like harkening back to the original data that we defined, remember that we had 3 books defined by one author and 1 book defined by another author. So if we did this query, what would end up happening is we send 1 query to the database for books, and we receive both of our book objects back. And then for each book, that resolver is generally in GraphQL going to look something like, take the author ID and then query the author database to get it back, something along those lines. So what happens is, even though we're only getting 2 unique authors, we end up fetching those 4 times. We do 4 fetches for each of the 4. We do an author fetch for each of the 4 books. Not only that, but it's 4 round trips when we could potentially grab all of those. We know what IDs we need already at the point that we get to this part of our graph. So we could potentially grab both of those from the author's database at the same time. So yeah, so just to kind of reiterate, this 1 query kind of ends up transferring 8 objects over the network. It's 4 books, 1 author 3 times, and 1 author once, and it's going to do that in 5 total queries, which, keep in mind, all of this is a very, very simplistic graph, and a lot of your queries, I'm sure, are much more nested, grabbing much bigger objects that have a lot larger pieces of data in them. So that may not sound like much for this, but it can quickly kind of balloon in a real world scenario. You can go ahead and jump to the next one. So the solution for that really common problem, and honestly, there's not that many compelling arguments, I think, to not use DataLoader in a graph, just because of the way, in a GraphQL graph, just because of the way it functions and how simple it is to implement. The solution that we use anyway, and a lot of other people do, is the DataLoader library, which was originally created by the Facebook team. It's actually been moved over to GraphQL's domain in GitHub at this point. But all you do to set up a DataLoader is you create a new DataLoader object, and you pass it a function that takes an array of keys or IDs as an input, and returns a promise that resolves to an array of objects as an output. So usually what that ends up looking like is your DataLoader object kind of wraps your API call. And maybe there's a little bit of extra work that you need to do to shift your API calls or your API library so that it is always expecting an array and is always requesting multiple objects. And that's generally not a whole lot of work. So what happens is when you get this data loader object, you end up with this author loader, and author loader has a .load method on it that you just pass a single ID. So every time you want to fetch an author, you say, load ID 1, we're talking about Kurt Vonnegut maybe, or load author ID 2, or author loader .load 2, author loader .load 1. And what DataLoader does is it batches everything together within like a single event loop. So a single tick of the JavaScript event loop, everything that gets requested is going to get batched together. So all of those calls that we're getting from separate chunks of our graph are all going to be fed into DataLoader. And then after we have a tick of the event loop, DataLoader is then going to fetch all that data, return it all to everything that requested it as a single promise, and then it's going to be able to move on. What that gives us is kind of really nice deduplication of calls and resource fetching within a single GraphQL transaction. It also within like a single request. So the data loader kind of gets, you would instantiate it per request. So at the time the request comes in, you would instantiate the data loader, and then that data loader would get garbage collected at some point after that request ends, because the next request would just end up creating a new data loader. The data loader also, like if you have a nested query of some sort, it'll also end up memoizing all of those ID requests. So even if because of the way the event loop happens, or because you've got some internal promises or set timeouts or something that's breaking your event loop, data loader will end up memoizing calls to its previous calls, so that you still don't need to refetch all that data even on subsequent calls. It'll still refetch new stuff, but all the old stuff will get memoized and passed back. And again, you don't really have to worry about cache busting, because this is all intra request. This is all like a single request. We send everything back. DataLoader does have some tooling around it that if you want to shift how those batches get scheduled, like if you do have some set timeouts or some internal promises that do some weird stuff with the event loop, you can tweak how DataLoader functions and customize it a little bit. And each of those DataLoader instances also is going to have a prime method that can be really nice. Like if you have, some organizations or databases have multiple alternative IDs or ways that you might fetch a record. So you could end up with a data loader for each of those methodologies. And then when, the author data loader that uses an alternative ID fetches an author, it could just prime that data into the other author data loader, and you end up kind of getting the same thing and not having to like refetch both times because you're using alternative IDs. So just to rehash, like from our previous example, where we had to transfer 8 objects with 5 different round trips to the database, this would just implementing these data loaders in this graph would give us 6 objects with 2 calls to the database. So no extra objects and a lot less overhead when it comes to a round trip to the database. Back to you, Liz.
Liz, you're muted.
Hi guys, we're going to just have Sharif talk next about mobile. So I'm not sure what happened here. I'm just having difficulty. There we go. All right. So he's going to talk about mobile, and I'll pass it to Sharif.
Thank you, Liz. So my name is Sharif, and I'm not muted. Oh. So I work with EVgo for a couple of years now, and I've been working with mobile technology for maybe the past 6 years. So today I'm going to be talking about GraphQL from the perspective of mobile applications as a client. And specifically, I want to compare between GraphQL and REST APIs and how our mobile app currently at EVgo utilize the GraphQL and the benefit that comes with it. So my experience basically previous to working with EVgo was interacting with REST API, which is most of the applications right now interact with REST API. So typically in any startup, usually startups start with web services or web application as a client, and then mobile comes as a second choice. Not always, but most of the time, or most of the client I started with, and that resulted in APIs that is created and tailored for web pages, which is much bigger real estate, and requests are typically request much more information from the backend. So when it comes to mobile, we have to interact with the same API. Otherwise, the backend will have to work double to create a tailored API for mobile. But we end up anyway working with web APIs. So as a mobile engineer, I have to do the request, and then create my models on the mobile app, and then with REST API, I would request all the information that the endpoint is giving me, and then I don't have any say on what information specifically I need. GraphQL now give me the freedom that, for example, in a user object, I can request as little as one field for that user object to make sure, for example, that that user exists or that user is logged in. And then next page, when I have to present a lot of information about this user, I can request more information from that object. That typically affect the performance of my request. The first request, if I request one field from the graph object, will be way faster than requesting the whole graph object if I need to. So GraphQL give me that customization benefit, and also reduce the work on the backend, because the backend does not have, they create their models based on their database, and any client with any size of UI or any size of information they need, they can request and combine calls for these APIs. Next slide, please. All right, so I want to talk about some drawbacks that I encountered when I started with EVgo that I see when I use the graph versus REST. So there is a lot of benefit, as I mentioned before. However, there is some a little bit of drawbacks that I need to also point out in my presentation today. The first thing is, as like, for example, I work with iOS application, and both iOS and Android, they need to utilize Apollo SDK, which basically generates the models for you. So basically, you're gonna have to Apollo SDK basically generate nested structs for you, and to deal with these models in your app, you're gonna have to type alias a lot of. You don't have to, but instead of getting a user and the user has an account, and then the account has a receipt, for example, like this is the hierarchy of the object on the graph, and this hierarchy transferred to our code. So instead of every time referring to a receipt through all this hierarchy, we type alias this stuff. So I find it a little bit not very flexible that we have to deal with generated code through the Apollo SDK. Also, we had to do extra work to include dynamic headers for our request. So if you need to include any authentication token or any request ID or anything like this, you're going to have to intercept the request before you fire it from your app, add the dynamic dynamic headers, and then fire the request. Also, joining EVgo the first time, dealing with the GraphQL, it has its own learning curve because it's not typical industrial standard. I had to read about mutation, I had to read about query, I had to read about Apollo SDK and how to use it. So that learning curve also add to the overhead of the of using the graph from the client perspective. Next slide, please. Next slide. Next slide. So I want to talk about performance because also when we first implemented and used the GraphQL here at EVgo, we noticed some performance issues, and this is due to like the old habit of using API REST APIs. For example, if we see an endpoint of a user that has maybe 20 fields on it, typically like old habit with REST API, I request all the 20 fields at once, and then later on I can use whatever I need to. But it takes you sometimes to get used to the habit of you can request only one field. And also working with the backend with the Apollo Studios, so you can analyze each request and what sub-request that happens in the backends and what is the time frame for each sub-request. So you can see all this information and see, oh, this is expensive call, so maybe if I eliminate that field, it will be much better, and maybe I can customize my UI to basically tailor to the performance of the graph. So we went in EVgo, we went a lot with a lot of session with the backend to see which requests are more performant than another, and which specific field are more expensive to request. And we were able to tailor this to our UI and optimize our request to be much more performant. I think, do you have next slide? I think that's it for me. Yep.
Yeah. Okay, we'll move
Thank
on.
you.
Great. We're going to be moving on to Juliette, and we'll talk. Julia, you can take over from here.
Perfect. Hello, I am Juliette. I have been with EVgo for just over 3 years and primarily have been working on our operator client and our Falcon infrastructure here. So what I will be introducing you today is the Apollo client library that we use to implement GraphQL on our front-end clients. Our implemented structure, data caching with Apollo client, and how we've component tested using the Apollo client resources that we have available. So next slide. Cool. So Apollo client allows us to manage state and local and remote data with GraphQL in our operator client repository, which it is a repository that manages operator portal type application front ends. So the core Apollo client library provides built-in integrations with React, which is useful for us as React is the library that we leverage on the front end. And with this React integration, Apollo client has offered myriad features to be used for query making, data caching, and testing components and the queries and mutations that they implement specifically. Go to the next slide. So our implemented structure kind of looks like this. So we have all of our Apollo files in a singular folder, which is awesome. This helps us to keep track of and navigate all of our queries and mutations that we are making to our GraphQL server API that we've mentioned a ton of. But it also has allowed us to set up our own local resolvers, queries, and mutations on the front end. So some examples of this are our UI resolver, which allows us to fetch and cache information about the current state of the apps apps UI to be used across the code base. And then similarly, our login resolver, which allows us to internally manage the state of the user's authentication with Firebase when they're accessing the operator portal. We have what are known as entities in the Falcon ecosystem, and these entities are objects such as chargers, sites, drivers, etc., all the things that you think we would be managing as an EV management company. It's a total EV company. So our queries are also thoughtfully organized by entity type in the front end. So we're able to efficiently pull and navigate necessary queries and mutations into our components as we're writing them. And for our actual use of queries and mutations, Apollo clients use query, use mutation, and use subscription React hooks are fully typed, and generics can be used to type both incoming operation variables and GraphQL result data, which is pertinent as operator portal is fully in TypeScript, and this also helps us test more efficiently. And next slide. So for our implementation of data caching, we have implemented mostly what Apollo client suggests. So to initialize Apollo client caching, we created an in-memory cache object, and we provide that to our Apollo client constructor when we first initialize the app. And the in-memory cache constructor accepts a variety of configuration options for caching, but we've set up our cache with just the default options that are provided by Apollo. With this, we can read and write data directly to the Apollo client cache without communicating to our GraphQL server. So this means that we can interact with data previously fetched from the server and with data that's only available locally, such as those local resolvers that I mentioned earlier. And again, it allows us to pull in any data that we've already fetched, so we have access to that throughout the application without having to refetch data. The write query method enables us to write data to our cache in a shape that matches a GraphQL query. So with our get UI query that I mentioned before, which is our UI management internally in the application, we're writing the get UI query to our cache to store data locally about the current state of the UI of the application. So this can indicate whether modals are open or whether we have success messages on the screen and things like that. But for individual queries, by default, the use query hook checks the Apollo client cache to see if all of the data you requested is already available locally. Because like I said, when you make a request, it is stored to that Apollo client cache. And if all the data is available locally, use query, that hook that we're calling to actually fire off a query, it's going to return data that doesn't query our GraphQL server because it already sees it in the cache. So this is Apollo client's cache first policy, and it is their default fetch policy. So in most cases across our application, we are using this fetch policy. And in many cases throughout our application, we are implementing the fetch policy called network only. So this means that Apollo client executes the full query that we are requesting against the GraphQL server without first checking the cache to see if that data is already available in our stored cache. But as soon as we do make that request, the resulted data is then stored in the cache. This prioritizes consistency with server data, but it can't provide an instantaneous response when cache data is available. And the most common use case for this is when we create a new instance of an entity. So for instance, if we're creating a charger, we'll have the create charger mutation. And as soon as we call that mutation, once we've created that charger, we're going to want to refetch all the chargers to make sure that we get a new list of chargers with our newly created charger. So with this, instead of just pulling the chargers data that we already have in our cache, we need to pull the chargers list again because we need to get that updated list. So we are currently in the process of auditing the use of this network only fetch policy. We will validate if we need to update the cache instead. So usually when the cache, the cache isn't automatically updated when the response data isn't related with the query type, the mutation doesn't return the data with the same order as the cached data. The mutation adds or removes items such as the creation of a charger. So yeah, again, if we're adding a new charger, we should update the list chargers cache specifically. And we don't necessarily have to make that request to the database to get that newly created charger because we've already added it to our cache locally. In general, it's not that hard to use Apollo cache, which is awesome. We just need to pay attention to the variable names that we use for each query so that they're all unique and we can have unique subsets of data and keep track of all of our cached data locally. And then there is a Chrome dev tool that also helps a lot in handling cache as well. So we're going to be continuing to improve our caching system on the front end, leveraging these Apollo tools. Next. So testing with Apollo client. Every test for a React component that uses Apollo client must make Apollo client available on React's client, excuse me, context, which is the way that we share global data throughout the application. We've achieved this by wrapping our component tree with the Apollo provider component. So this component is then wrapped, it basically wraps the entire container of our application, and it allows us to use what Apollo calls the mocked provider component in our tests. The mocked provider component enables us to define mock responses for individual queries that are used in the components that we are testing. So this means that our tests don't need to communicate with our GraphQL server, which removes an external dependency, and it improves our tests reliability because we're doing it all locally. And we've created a helper function that returns the rendered mock provider. So what we've done is we've created this function that we can call from any of our tests, and we pass the element to that wrapper effectively. And then we pass any mocks that go along with that element. So the mocks are going to be looking something like each request that we call within the app or within the component itself, and then the resulting data from those specific requests. So those mocks would look like an array, and for each request or each mutation, we can pass both the request and the result. And then the test will actually test to make sure that when those like queries and mutations are called, that the data that we're defining as results are going to match, and that's how we're going to be testing that. So that mocked provider just kind of helps us do that. It takes all of the mocks that we're passing for these queries. So again, we don't have to hit our external GraphQL API. We're just doing it all internally. We're able to match the data structures. We also have a wrapper function that is very similar to this, but it's called render with mocked provider and router. So that's the wrapper that we would wrap around the component that we are testing. And it wraps the function in the mocked provider component, which is what we talked about above. And it wraps it in a memory router. So then this passes it basically all the way down into a route. So our element can actually be processed as a route from React Router DOM. And excuse me, this is necessary for all components that behave as routes within the application. So all of our parent views or any of our like pages that you could land on. So any of our list pages or our detail pages, all of that stuff, it allows us to actually process those as routes. And then within those specific components, we can also use things for routing within the application, like use navigate and things like that. So those must be wrapped in that mocked provider and a memory router. There are some cases throughout the application that we have not optimized testing for this. So in those cases, we just wrap those elements in the mocked provider within the test itself. And then to actually test the queries and mutations that we are running, we use just spies. So we'll just call the spy on the Apollo use mutation or Apollo use subscription or use query hooks, and we'll spy on those hooks. And then once those are called, we can either test the return value or the implementation itself. And in cases where we need memory router, we just wrap the component in the memory router, like I said, within the actual test itself versus calling that helper function. So it all kind of basically in the end looks the same, but the tests are run differently. And they're not in these tests that we're using to just spies, we're not wrapping them in that mocked provider. So we're having to test all of these queries and mutations individually as opposed to passing them as mocks in the object that's consuming in the mocked provider. And next. So thank you so much for coming and being here. We're so elated that you could come and hang out with us for this afternoon. I know that it's been a long couple of days coming to all of these different talks and learning a ton of new stuff. And as far as our our Apollo client implementation, we are constantly learning and evolving our usage of Apollo client within the Apollo client repository and across the application. We have a very good relationship with Apollo here at EVgo. So we've learned a lot in the past year working on a newer part of the repo, and we've created new patterns of structure, caching, testing, and more. And we'll continue to audit and improve the quality of our code universally. And it's awesome because EVgo's afforded us the opportunity to evolve with Apollo and newer technologies to make it easier to implement and use Apollo with our other tooling. And that is it. Thank you so much.
Great, you guys. I want to pass it over and first thank EVgo and all the engineers here, but I want to pass it over to Q&A and see if we have any questions here. And if you want, there's a question on the Zoom. If you have any questions, please put them there. We'll be happy to answer them. I got one. It looks like somebody already got an answer on entities. What are they? But I'll pass that to just to make sure that that's clear. We can pass that question over to Brandon.
Juliette, actually, I think that came up with Juliette's.
Oh, maybe it came up with
I think they were
Juliette.
just asking what she was.
Oh, okay.
What she was referring to as entities.
Okay. If there's any questions, just throw them in the chat and we'll be happy to answer them. So we'll wait for a couple questions there. Any questions, you guys?
Also, if you're coming from HackBuddy, just and if you're kind of trying to get familiar with the stack, feel free to ask any questions about GraphQL itself. I mean, there's no dumb questions here. We'd love to have you ask any questions.
I do have one question. It's is GraphQL easier to manage security-wise than REST APIs? I'll pass that back to the team.
We can't hear you, Brandon.
Yeah.
I got it. I would say no, it's not. There are some more complexities with dealing with a graph. Essentially, you end up attaching a lot of the security information and the token to the context that's used throughout that request. But then there's just more places where you need to check authorization and things like that to make sure, like within specific resolvers, that an entity has or a user or a client has the rights to grab a specific field or thing. So it's definitely doable, and there's plenty of tools and methodologies out there for it. But I would say it's probably not easier, unfortunately.
Anyone else? Oh, sorry about that. How long has the team been using Apollo client is the next question.
I know we've been using it as long as I've been here, but Roger is going to be the person to answer that one.
Well, Apollo client, again, when we're talking about Apollo client, there's several, right? You've got the mobile client, which is an SDK, right, for both iOS and Android, and we're also using the web client. So in all cases, since the beginning of us using GraphQL, so we've been building out and using GraphQL for the last 4 years. And it wasn't, and we launched our mobile app live with the production graph this past December. So we've been using it the entire time.
There's another question. Was there a reason to start using Apollo? Were there any other stacks considered? And then the person says, I'm not familiar, so.
Yeah, I think part of what we're trying to kind of get across in the various talks that we're having is the reason why we started using Apollo really was to kind of have more control over what we're doing and not having this traditional REST APIs that Sharif was talking about, where we're calling an API and we're getting all this data back, right? Whether we want it or not, right? So a large part of what interested us about GraphQL was the ability to kind of create our own entities and create our own ability to query and just what our clients want, right? Mobile needs some specific things, right? That really only matter to them, right? Operator client or portal, as we call it, which is basically our admin tool to administrate our network. There, then you need more information. You need, because it's more kind of CRUD operations when you're managing within like an operator portal thing. So all of this flexibility is kind of really what appealed to us. The other part of it is a client can implement something, and we talked about this as well. We can implement something with the best of intentions, and really think it's performant, right? But once you actually get into a production environment and people are hitting your app, and we've done performance testing, and that's where you really start to see where there's opportunities to improve performance. So we've had several opportunities, and it's been really easy for us to manage it, where something in the mobile app may take a little bit longer than we like, right? And we're able to look at Apollo client, or excuse me, Apollo Studio, and see, what's actually happening, and really kind of see and see where a bottleneck might be, and then we can have the team immediately target and improve that particular resolver that's actually getting the data, and the client doesn't have to do anything, right? Mobile's like going, oh, it's faster, great, right? So that flexibility really is something that really is something that I think is the biggest strength. Now I'll let the rest of the team kind of speak to that, but that's just from my perspective. Brandon, Juliette, Sharif, Vijay, you're on the team as well.
So I think GraphQL definitely makes things a little bit, as far as newcomers go, right? I think it makes it easier to understand the patterns that a company may be using in terms of working with multiple different services. That's kind of the one insight that I've had recently, just while also working on GraphQL projects, is that there's a very good pattern that follows with resolvers, type defs, being able to write queries and mutations. I think that kind of pattern is sort of missing from traditional REST architecture. And I apologize, I'm at the auto show, so it's a little loud. But essentially, I like that because it gives me something a little bit easier to kind of follow. Sometimes when you work on other company code, you kind of tend to think that you work with a lot of different services, and some of them are written kind of in a spaghetti-ish way. So GraphQL kind of forces you to kind of work in an architected patterns way, which I really like. So that's something that I think GraphQL brings to the scene. That's why I actually enjoy using it.
Yeah, and I think it's also important to mention that by its nature, it is a self-documenting system, right? Our entities clearly are identified, assuming that the developers are clearly defining them in the type defs, but we have that common language, right? And you as a client don't care that the data is coming from a database, or the data is coming from a NoSQL, or it's coming from another REST API under the hood, right? That is the single biggest thing I think that really makes GraphQL powerful, is the client doesn't care. It just tells you what it wants. And then we can end up retooling things that is in a Postgres database, and decide, hey, we can make this even more performant because we're getting hundreds of thousands of requests a day. Let's put it over here on something more performant, right? Again, it's that transparency to the clients that really is what makes it powerful, right? And then things to consider as you go into federation and is the idea that Apollo themselves is kind of looking at things as, we have a super graph for us that's relatively internal, right? We can choose to expose a portion of that to a public API, right? We have companies like PlugShare that have individual reviews from customers who are actually out in the field using the PlugShare app, right? And you know, uploading photos and making comments, you know, and providing feedback on our chargers as well as other chargers. We can in the near future say, hey, PlugShare or any third party who is also doing a graph, we're going to link your portion of your graph with ours. So now the clients can now pull in and look at those reviews that are coming from another party, right? So Apollo really is kind of going down this path of creating what I would call a global super graph. I don't remember what term they use. Maybe Brandon, you might, because you were at the conference, but that vision is kind of where this is headed. So I think it's important to talk about, you know, here's our vision of what we're doing right now, but the larger picture and where things are heading is that direction. And for me, understanding the products that we want to launch and the things that we want to do as a company, being able to do that very quickly and is really the power of GraphQL from my perspective. Sorry, I know that was rather long-winded. So if anybody else has any to add?
I think that's so just to add to that, right? Like, and I think, thank you for like saying that.
I think that's at time. I appreciate everybody coming today, and thank you so much for joining us. And we hope to be doing these with a lot less technical difficulties like we are having right now, but I appreciate everybody's questions and thanks you for attending, everybody. We really appreciate you coming today. Thanks.
I'm wondering if we can just continue a little bit more because we started late, Liz, and we were about to answer something that I think that's important. Or is it too late?
Everybody's leaving.
All right. We left
Okay.
early. We left early. Thank you guys for coming. Those of you that work with Vijay and his meetup group, feel free to reach out to us with any questions that you have. And I appreciate your time.
Absolutely. Yeah. And feel free to reach out to me directly too. Like if you're from HackBuddy, and I'll definitely get your questions answered if you didn't have a chance tonight. Thank you.
And as far as the question about learning resources, Apollo Client and Apollo itself has tremendous documentation and actually a very comprehensive tutorial for starting out with GraphQL. That was actually my coding challenge to start at EVgo, is just kind of following that and creating a small application with that. So that would be my #1 recommendation if you want to start getting into GraphQL and Apollo Client. So, but yes, thank you everybody, and hope you all have a wonderful weekend.
Bye all. Thank you.
Bye.